A researcher wishes to estimate the proportion of adults who have high-speed internet access. What size sample should be obtained if she wishes the estimate to be within 0.02 with 99% confidence if, and then there are two parts, part A, she uses a previous estimate of 0.34, or B, she doesn't use any prior estimate. So recall that to compute the confidence interval for the proportion, we just use this formula, the p hat plus or minus z star times, and then it's just the standard error, which in this case is p hat times 1 minus p hat over n. Now, where the expression to the right of the plus or minus is called the margin of error. So we're going to write this using an inequality symbol because we often want this term less than or equal to a certain number. In this case, we have ME is greater than or equal to that margin of error. So for p hat, we're either going to use a value from a prior survey, or we're going to use 0.5 if no value is available, because the 0.5 is going to produce the largest sample size possible. So why not just go with the largest sample size needed? Well, larger samples produce smaller margins of error, right? Larger samples also cost time and money. So we can use a little algebra and solve for n directly, and we get our formula. So it's n is greater than or equal to, we have z star over me squared times p hat times 1 minus p hat. There is a way that Statcrunch can compute this for you automatically, but I'm going to recommend that you learn how to use this formula and how to use it on the TI. Unfortunately, that's the only way that for testing purposes as of this making of the video that we're able to do this. So we see our formula. Let's go ahead and fill everything in. So we know z star for 99% is 2.576. And recall how to figure that out if you don't remember that. You're going to go to distribution and go to number 3, inverse norm. Our area, if 99%, we have 0.01 left, right? But we have it in 2 tails, so we divide it by 2. And you can go to the right if you need to, left or right, and then paste. And we get 2.576, and we discount the negative, because we're just looking for that critical value there. So that's what z star is. And then our ME, the margin of error, it says within 0.02. So that's our ME. And then it says if we're going to use our previous estimate, that's what p hat is. So it's going to be 0.34 times 1 minus 0.34. Okay, so I put all this in the calculator, and I got 3,722.67. So we always round up. Even if that were like 0.2, we want to round up to the next one. So 3,723. So now what happens if I don't have a prior estimate? How many more people would I need? In fact, how many total would I need? So I do everything the same. So I can go over here and press second enter, pull up what I just did. And the only thing that changes here is instead of 0.34 as a prior estimate, it's just going to be 0.5. And let's change this other one to 0.5. Okay, I think that's right. And then press enter. So 4,140, we always round up. No matter what that decimal is, it rounds up to the next one, 4,148. Now let me show you on Statcrunch how we can get this to work. It's a little tricky, but I think it's worth showing you. So let's go ahead and go to Statcrunch. Okay, we're going to go to stat. We're talking about proportion stat. It's just one sample. And this time, instead of going with summary or data, we're going to go over here to sample size and width. Okay, so we want a 99%. And we're using a prior estimate of 0.34, so that's our target proportion. Now it's the width that can be a little tricky. It's 0.02 margin of error, which is actually a 0.04 total width, right? We just double whatever our margin of error is, right? Because it's 0.02 to the left and 0.02 to the right. Hope that makes sense. Oop, actually I put in 0.02. I meant to put in 0.04. There we go. And that's our 3723. And do the same thing if it's 0.5, put in 0.5, and we get the 4148. So I hope that helps.